Hey everyone, today we're going to be looking at properties and changes in the world of chemistry. Remember that chemistry is the study of matter and the changes that matter undergoes. So, in order for us to actually study this, we have to have a good grasp on the different types of properties of matter that we can study, along with the different types of changes that matter can undergo. So, really, how do we observe matter and how can matter change is what we're going to be looking at today. So, let's first off start off by talking about what a property is. A property is some sort of characteristic or attribute of a substance. Back in the day when I used to teach at the Science Museum, one of the students, one of the elementary school kids, basically came up and said, "A property is something you own." And I was like, yeah, actually, property is something that something owns. And so when I kind of like to think of it, right, like if you have a gold coin, right, the coin owns that gold color. It is a part of that gold coin, that yellow color. It is a characteristic or attribute of that substance. And there are four types of properties that we're going to be looking at today. The first one is a physical property. So, for example, ice is solid. That is an example of a physical property. A physical property is going to be a characteristic observed that does not change the identity of the substance. So, when I go ahead and say that my ice is solid, I am observing that characteristic about ice. It didn't change. It started off as H2O and ends as H2O. So an easy way to identify if your physical property is in fact a physical property is try to identify what it was before and afterwards. Before you said that ice was solid, it was H2O, and afterwards it was still H2O. Next, we have chemical properties. These are going to be referring to the ability for a substance to react. Basically, how good as it is it at chemically reacting with something else. A good example of a reaction would be a precipitation reaction. Precipitation, the word precipitate refers to a solid forming when two solutions mix. So if you form a precipitate, that is evidence of a chemical reaction. Flammability and burning is also an example of a chemical reaction. So, generally speaking, when we talk about chemical properties, we're talking about how good a chemical is at reacting with something else. An excellent example of a chemical property is the inability for the noble gases to react. The noble gases are the rightmost column of elements on the periodic table. They have helium, krypton, xenon, argon, neon. These are all very unreactive elements. The next two are kind of opposites of each other. We have extensive and intensive properties. An extensive property is referring to a characteristic that depends on the amount of matter. It depends on the amount of stuff that you have. So the property will change depending on how much matter you have. So, for example, mass, if I have a single gold coin or 50 gold coins, the mass of the gold changes depending on if I have more or less. Volume is another example of an extensive property. If you have more water added to the beaker, that increases the volume. If I remove some water, then the volume decreases. That number changes. An extensive property depends on the amount of stuff that's present, whereas an intensive property does not. Intensive properties are characteristics that do not depend on the amount of stuff present. A great example of this, and I want you guys to see if you can think about it, is what temperature does water boil at? What temperature does it go from the liquid to gas phase? And if you're thinking 100 degrees Celsius, you'd be correct. This cup of water here is boiling at 100 degrees Celsius. If I had a bathtub full of water, it would boil at 100 degrees Celsius. If I had a thimble of water, it would boil at 100 degrees Celsius. That number does not change, and therefore, boiling point is one example of an intensive property. Regardless of how much water I have, water boils at 100 degrees Celsius. You might know this in Fahrenheit, it boils at 212 degrees Fahrenheit. The last thing we're going to be talking about today are types of change. It's very similar to what we were talking about earlier with physical and chemical. So I want you guys to keep that on the back of your mind, physical and chemical. The first one we're going to look at is a physical change. Now, change is a part of the word, so somehow the matter has to change. The substance that you're looking at has to change. But the chemical formula or identity of the chemical does not change. It's a change in the matter that does not change the identity of the substance. Tearing, breaking, shredding, ripping are all examples, right? If I have a piece of paper and ripped it in half, I still have paper. And these are example of physical changes. A less obvious example are going to be phase changes. So changing from solid to liquid or liquid to gas. These are examples of physical change. You should be very comfortable with the different names for moving between solid and gas, liquid and gas and solid, so melting, boiling, all of these words here and the direction at which they go, you should be comfortable with. And they are all examples of physical change. We're also, another example, of a physical change is dissolution or dissolving. So if I take salt and dissolve it into water, that is changing the matter, but it's not changing the identity of the matter. So that is just going to be a physical process. And last but not least, we are in a chemistry class, so we want to be comfortable with chemical change, or also known as chemical reactions. Whenever I ask students what chemistry is, the first thing I get is, it's the study of chemical reactions. And you're not wrong. We look at a lot of chemical reactions in this class. But generally speaking, when you see a chemical change, this is going to be when one or more chemicals, substance, changes its identity, its formula, into one or more different substance. So when you have an explosion, when you have that precipitation, when you have that flame, generally speaking, what's happening is the chemical formula is starting as a reactant in one form and turning into a product in a different form. And that's going to be your chemical change or chemical reaction. That's it for today. If you guys have any questions, feel free to shoot me an email.